Okay, so now let's look at one where we actually don't have a graph to look at. So given the function of f of x equals -4 as x approach is less than or equal to -1, x squared plus 2 as x is greater than -1 and less than or equal to 3, and 4x minus 1 as x is greater than 3. Determine the values of x for which the function is discontinuous. Additionally, state the type and whether it is left continuous, right continuous, or neither. Okay, so if we look at this, this is a piecewise function. These are all polynomials. So there's no value of x where these are going to be undefined, where I'd have that open circle, or that they're going to approach infinity. So I don't need to worry about any of that. What I do need to look at is what happens as we go from one piece to the next. So I may have some issues at x equals -1 and at x equals 3. So let's see if we do. So let's look at what happens when x equals -1. Okay, so first let's figure out what is f of -1. All right, f of -1 equals, so when it's less than or equal to -1, the answer is just, the output is -4. All right, so let's see as I approach it from the left and from the right. So as I approach -4 from the left, those are numbers that are, sorry, not -4. As I approach -1 from the left, so numbers that are smaller than it, I'm in this piece, so it's just going to be -4. As I approach it from numbers that are larger than -1, now that puts me into this piece. Those are x values that are larger than -1. So that's going to be -1 squared plus 2, which is 1. So we can see that the limit from the left and from the right are not the same. So the limit does not exist there. There's going to be a problem. So I'll just write that out. The limit as x approaches -1 of f of x does not exist. So we can see though that so that means we're going to be discontinuous at x equals -1. This is going to end up being a jump discontinuity because it's going to jump from -4 up to +1. So this is going to be a jump, and then it's going to continue on after that 1 using that formula. And we can say this is continuous from the left. It's left continuous because the limit as we approach it from the left is -4, and the function at -1 is -4. Those are the same. So we can say this is left continuous. And sometimes it helps if you guys want to graph this afterwards and you can see visually what's happening here. All right, so let's look at this next one. So the only other problem that I'm going to run into is this 3. Let's check out what happens at x equals 3. All right, so let's first evaluate what is f of 3. So f of 3 puts me in this area here because it's less than or equal to 3. So f of 3 is 3 squared plus 2, which is 9 plus 2, which gives me 11. All right, so let's see what happens. So the limit, as I'm approaching 3 from numbers that are smaller than it, so from the left of the function, well, that's going to be using this formula. So that's going to be the limit as x approaches 3 from the left of x squared plus 2, and then using limit laws to evaluate this. This is a polynomial, so I can simply replace the x with a 3, so I'm going to get 3 squared plus 2, which is 11. If I look at what's happening from the right-hand side, so looking at numbers that are larger than 3, that's going to put me into this function using that, or this piece, not this function, this piece using the 4x minus 1 formula. So that's going to be the limit as x approaches 3 from the right of 4x minus 1. So again, this is a polynomial, so I can just go ahead and evaluate that. So I'm going to get 4 times 3 minus 1, which is 12 minus 1, which is also 11. So all of these are the same, which is great. So that means that because we have that the limit as x approaches 3 of f of x is 11, because from the left it's 11, from the right it's 11, so it's 11. And that's the same thing as the function evaluated at 3. I also got 11. So that means this is going to actually be continuous at 3. So the only time where I'm going to have a discontinuity is right here at x equals -1. So here I've actually graphed it for you so you can just kind of visually see what's happening and why we're discontinuous at -1, and that's because again here it's -4 and it's including that. So that's why it's left-hand continuous, and then it jumps up to here. And then at 3, which is where we're going to have that problem right here, it ends up being a solid circle. So I actually could draw that entire thing without having to lift my pencil. So the only place that it's discontinuous is at x equals -1, and it's a jump discontinuity. Not -1, it is left side continuous.